Hello everyone, and welcome to our video on compound interest and the TVM Solver. So compound interest is usually used on loans or investments of more than 1 year. So like a savings account is going to be compounded monthly, or any type of major investment, it's usually compounded monthly. I mean, they could be different types of compounds, but what that means is, so every month the interest is being calculated and added to the accounts, and then the next month it's doing the same, and then the next month it's doing the same. So it's forever doing it. Whereas our simple interest from the previous video is just doing it one time, just during the whatever the one time span is, and then that's it. Okay, so compound just means it's going to continuously do interest to the initial amount that was invested or needed for a loan or whatever. All right, and it does have this formula, so if you want to try this, you can. We're gonna summarize it though using our calculator, or a nice function in the calculator. Okay, so what this is, and this is a different way to write it too. So they use different letters to mean different things. So they're saying, here's another way to look at it. So A, they're saying, is a future value. Sometimes we could just say FV is future value. P is the present value, or also still principal. Okay, so that's still principal if we wanted to look at it like that. But we could also say PV, and then 1 plus. Now this I is what's interesting, because this is not an interest rate like the decimal. It is some weird I, but we'll still plug it in right there. And then the N is also something involving more of an equation to it. It's not just instantly given. You have to do a little tiny bit of work to get there to it. Okay, but the I is the interest rate period, which is taking your R, your interest rate, and dividing by M. M is the number of times compounded per year. Okay, so we'll get into all these. And then the N equals M times T, so it's the number of periods that we would have getting compounded. Okay, and time is T in years again. So the main reason I wrote it is just to see it and to compare the letters. But all the calculations we can do will be a lot faster if we use this time value of money calculator, which is called a TVM Solver. And it's on an 83, 84 Inspire, so there are links there. You could just Google TVM Solver on TI-84 or whatever. But assuming, like, again, we can kind of use this if it's an online class, I'll be doing a free resource online to show you what I use. All right, so let's break down what all this is, though. All right, so in a TVM Solver, so the function in a calculator will open up, and it will give us all these different variables. All right, so they are a comparison to what we have in our, like, simple interest and the compound interest formulas, where we could start off like, so let's not go top to bottom. Let's just make a note of this. So the present value, PV, is present value. This is also, again, they might use the word principal just to put it. Okay, and it'll have all sorts of stuff that might not be used in every single problem. So some of it we might not have. That's okay. Like PMT means periodic payments. That means like some type of amount going in an account every month, say like $100 per month into an account, something like that. Future value is FV again. Over here, these two numbers should always be the same. Same number. I guess there are maybe some very rare cases where they're different, but almost every time they should be the same. And there's no examples that I do where they're different. Okay, so they are going to be the same number. So this P over Y would be payments per year. Okay, so it's a number of payments per year. So for instance, maybe like a cell phone bill, you have to make a payment every month. So that would mean that this would equal 12. Or if we're investing money into something that's gaining interest, it would be the number of times interest is compounded per year. So it's some numerical value. Often it is 12, because kind of the most common compound is monthly. Okay, so anyway, these are the same number. In our formula up here, these would be the letter M. Okay, so M is the number of times compounded per year. So if we wanted to compare letters, that's what that one is. Okay, and then kind of going back up, notice this capital I% is the interest rate as a percent. So you do not convert it like you would have for simple interest, or if you were using this formula above. So I'm not even going to use this formula. Okay, so but simple interest, we still need this formula. Okay, so simple interest, we convert it to a decimal. Here we do not. So I%, we just leave it. And then the number of payments. Okay, so this is the same as that little n up in that equation. So the number of payments would be the number of times compounded per year. So this is, using that formula, it's m times t. Okay, so number of times compounded. Or you can even use it as, I usually prefer the c over y. It's the c over y times the time. Okay, so it's that number times that number. So if you have to make a payment every month for 5 years, it would be 12 times 5. So you would be making 60 payments over those 5 years. Okay, so that's that lingo. Let's put it to practice. Oh, one other side note. When we start to plug values into these, we usually consider incoming cash as positive and outgoing cash as negative. So like when we deposit a value, so if we deposit $1,000 into an account, that would be considered negative. Okay, because the other kind of way to look at it is like, if I deposit $1,000 into accounts, I kind of no longer have that $1,000. It's in the account. The bank has it or whoever has it at that moment. So we can kind of say, well, I just spent $1,000. But at the end of whatever, I would assume I'd get it back with interest. Then that would be a positive value. Okay, so anyway, so there's these. So if you have this document, you could click on it and work on it or to see those. But again, I'll show you the free resource. Okay, so common number of compounds. Okay, so these are compounds per year. I just use C over Y. Again, it could be the same as P over Y. So annual means it's getting compounded one time per year. Quarterly, well, there's 4 quarters in a year, so that means we would have 4. Semi-annually, well, I guess I kind of went in a little order. Semi-annual would be 2 times a year. Monthly, there's 12 months in a year, so that means 12. Weekly is there's 52 weeks in a year, or again, they might say just use 50 for a nice round number. Daily, if it's compounded daily, then it'd be 365, or again, they might just say use 360 because it's a nicer, rounder number. All right, so let's see how this works in this video. So we've got one problem that I want to do. It's 2 different kind of parts, though. Okay, so on this example, it says find the compound interest earned and the compound amount if $1,000 is invested at 1% compounded annually for 2 years. Okay, so we've got these different numbers that I'm just trying to underline. Okay, so as soon as we see compound interest or the word compound, that means we can use the TVM Solver. So the TVM Solver that I'm using, so on my calculator, so Desmos is where it no longer is useful because it doesn't have that calculator. So now we move to something different. All I did was type in TVM Solver into Google. And I kind of prefer, so you could try them out. So this one is actually the same as this one. But I like this one's a little better because it also tells you what all the stuff is. Okay, so and then it looks something like this. And so if you have an 84, 83, or Inspire, you also can find a menu that's something similar to this. All right, so let's find out what happens with all these. Okay, so what I'm going to do is just kind of have this to the side for now. And I'm just going to copy all of this, all just with the blanks for now. So I'm going to do in equals, and then I% equals, and then PV equals, and then PMT equals, and then FV equals. And then we've got our P over Y equals, and then our C over Y equals. So I am just copying that menu, so you can't see it right now, but that's what I copied. So I just copied this, and right now, so some of these numbers are already in there. That's fine. We can change them. Okay, so I'm just leaving it blank for now. Okay, and then now I'm just going to fill in whatever's important to us in this. Okay, so it says find the compound interest, that should be earned. It says eared. Okay, so earned, and the compound amount if $1,000 is invested. So that's our present value. So we're presently investing $1,000. Following the rules about putting money into accounts, that would mean we're going to make this negative 1,000. Okay, so this is also just the way the calculator is programmed. So so it's negative 1,000 is technically what goes right here. Okay, and then let's see what else we got. Okay, so they said 1%. So that's where you just put in 1 for the I%. So don't convert it. So it's just 1%. It's ready. Compounded annually. So we said, hey, that's 1. So that's our C over Y is 1. And then instantly P over Y is the same number. So they're connected. And then it says for 2 years. Well, that's where that would go into this capital N. Remember, the capital N is your C over Y times your time. So we have C over Y is 1 and our time is 2. So that means it's 2 that would be going into there. Okay, and what we're trying to learn in this, or find, it says find the compound interest earned and the compound amount. So that's after the 2 years. So that means we're finding a future value. Okay, so I'm gonna put 0. For now, I'm just gonna put 0. This is what we're trying to find. Okay, so it does want a placeholder, so I'm just using 0. Since in this statement here, it doesn't say anything about a payment. So payment would be like $500 every month or $500 every week. So that's not happening. It's just one sum put into an account and then it's moved on. So that means the payment is also just 0. So there's no payment being made. So let's just put 0 in its place. Okay, and so here it is. Here's everything. And then now let's go to our calculator. Okay, so I just want to plug in, make sure everything's good. Okay, so we've got 2. We've got 1. We've got negative 1,000. Payment is already 0. Future value, we just input 0 for now, and then those are each 1. Okay, and on this calculator, you can push the button to answer it. Okay, so I want to solve for future value, so I'll click on it, and there we go. Okay, so it's $1,020.01, and it doesn't look like there's any other decimal. Here's one problem that this calculator might have, though. It looks like sometimes, and this might not be the case on this problem, but sometimes it might round this too much. Okay, but I think this will get the job done in this problem. Okay, so we found it. Okay, so that's how we use this thing. So instead of using that formula, we can use this. And the reason that this is so much better is because this works in, so there's all sorts of other formulas for finance besides this top one. But this solver will work in all those different cases. So instead of working our way through a bunch of random formulas, we can just use this every time. Okay, as long as it's something that's being compounded in some amount of time. So compound monthly, compound weekly, whatever. Okay, so we got it. Okay, so we found it. Let me go ahead and just write that. So it's 1,000. So we did find it, and we got future value was $1,020. And if they said round it to the nearest cent, just put a 0 on there. Let me make sure I copied that right. Yeah, so there wasn't a 0, but I put it there. So they usually want it to the nearest cent for money stuff. Okay, so and then now we have to make sure we know what this answer represents. Okay, so going back to it, said find the compound interest earned and the compound amount. So this is the compound amount. Okay, so this here. So that's what the account is worth at the end of the cycle. Okay, so that's that portion. Because interest, kind of going off of what we did from simple interest from the first video, the interest earned would be the difference in our present value and our future value. Okay, so the interest is future value minus present value. And then on this case, we will keep them both positive. And then when we do that subtraction, we get $20.10. Okay, so I just kind of did that small. That's a dollar sign. It got a little messy. Okay, and we can see that here too. You might not even need to do the whole subtraction. You can see, well, the account is worth $20.10 more. So that is the interest that was earned. Okay, so that's it. So that's how we can find it. Let's go back to the calculator to show one other thing about this. So that was our answer. Notice, watch this. So if I plug in positive 1,000 into this, let me go ahead and change that back to 0 and then do solve. It's just made it its opposite sign. Okay, so it's negative. Okay, so it's just trying to interpret. So these should have opposite signs to it. So this is like we're losing money for some reason. So that's what the signs are trying to tell us. Okay, so that's what But again, just the way that's programmed. Either way, notice I'm not using a negative on this answer. I would still just say $1,020.10 is the future value. Okay, so be careful of those negatives. Usually, though, it's easiest to make the present value negative. Okay, so let's see the other one. Okay, so this other one. Again, all I'm going to do for it is just copy down all of these. So N equals, I% equals, PV equals, payment equals, future value equals, the P over Y equals, and the C over Y equals. And here we're recycling some of the same information. So they said the present value is 1,000, but in our program we would do negative 1,000. And then this is still 1% compounded, but now it's quarterly. Well, there's 4 quarters in a year, so the P over Y and C over Y is 4. And even at this point, you could plug it in right into there, into the in, instead of writing it out like I did in the first one. So I know this is part of that capital N. And then the 2 years, I can plug the 2 into that. So this is really just 8. Okay, and then there is no payment. And then the future value, again, just as a placeholder, I'll use a 0. That's what we want to find. Okay, so let's do it. So in our TVM Solver, and watch this. So it's not 4 times 2 is 8, right? So that's easy. But you can plug in case these numbers are bigger. You can plug it in and press enter, and it will convert it too. Okay, so 1. Let's change that back to negative 1,000. We have 0 payment. Let's go ahead and change this to 0, and let's change this to 4. And then look at that. I pressed entered, and it automatically changed the bottom. So this also is programmed to kind of know, hey, these should be the same. Okay, so there we are. Okay, and then now that it's all plugged in, I want to solve the future value. So I'll press solve. And there we go. And this time around, we can see, well, oops, it's not, well, not oops, but we can see, oh, it's got an 8s there. So it looks like we made 8 more cents on this different type of compound. So $1,000. Okay, so we found our future value was $1,020, and this time 18 cents. Okay, so that was the second part. That's the compound amount. Again, let me just make sure one last time I did. Yeah, so it's copied. So it made 8 more cents, and that's because it's getting compounded more often. Okay, so that means at the end of the first quarter, your $1,000 is bumped up slightly, and then from there it's getting compounded again. Okay, whereas this was just once at the end of the two, or the end of the first year and the end of the second year. So it's only 2 times of interest. This one had 8 times interest getting used on it. Okay, so that's why it's worth a little more. Okay, and then the interest amount, though, let's go ahead and put it up here. Our interest amount is the future value minus the present value. Well, we can eyeball that, I think. Subtracting, we would get $20.18. Okay, so there it is. So we found it. Okay, so there's our using our calculator. Okay, so I'm not going to touch these formulas. Okay, so I'll write them, or they'll be in these notes, but this is so much nicer. This is going to be so much easier to use, so that's what we'll stick to. All right, so really the only formula that's probably needed is the simple interest, because that's not programmed into the calculator, because it's kind of nice. It's not that big of something to worry about. Okay, but that's it. All right, so in our next video, we'll do a handful of other examples, but it's all going to be broken down in a similar way. So if you did want to try them yourself, if you have this printed out, or here they are, that's what we'll do. Okay, so thanks for watching. If you have questions, let me know.